Hello everyone. In this presentation, I will give a brief overview critiquing a topic that's the subject of a manuscript I'm currently completing. The topic is that of an increasingly popular method of inferring phylogenetic hypotheses called character mapping. I will show that character mapping is philosophically and scientifically untenable. The method leads to hypotheses that cannot be rationally interpreted as explanatory accounts of homologous characters. The problems outlined in this presentation highlight the greatest overlooked issue in systematics, namely a traditional failure to understand the only type of reasoning available to infer hypotheses. This form of reasoning is known as abductive reasoning or abduction. Character mapping is a method claiming to infer the evolution of phenotypic characters by way of placing those characters on a phylogenetic tree that was previously inferred from sequence data. Of course, this gives the incorrect impression that sequence data are somehow more important than other classes of characters, a typical failure of not understanding basic principles of reasoning in scientific inquiry, as I will discuss later. In some of the literature you might encounter, character mapping is called ancestral state reconstruction, but the phrase character mapping is more descriptively accurate. A recent example of character mapping includes this 2021 paper where the authors infer a phylogenetic hypothesis for spiders using only sequence data. The authors then map different forms of spider webs onto this tree and claim they are determining ancestral conditions for these webs. Another example is this monograph published earlier this year. The authors are considering the evolution of vocal sac characters among frogs. This was done by mapping vocal sac characters on a phylogenetic tree based only on sequence data previously published by other authors. I also want to make you aware of similar character mapping approaches that can be found in the recent paleontological literature. In this example, the authors take phylogenetic trees from different sources, combining them into a more inclusive tree, then mapping types of diet among non-avian amniotes. The basic critique of character mapping I present in this video also applies to this sort of character mapping in paleontology. So why is character mapping problematic? To answer that question, we first have to look at what has transpired during the last 60 years in systematics and identify a fundamental problem that I call filling the inferential void in systematics. That inferential void is the ongoing attempt to explain this question: how are phylogenetic hypotheses to be inferred? Not surprisingly, no consensus exists, but the solution has in fact existed for many years and only recently applied in systematics. There have been attempted solutions, but as I just mentioned, the actual solution has been known for many years, just not in systematics or evolutionary biology. Since the 1960s and up to the present, the principle of parsimony has been regarded as a way to infer phylogenetic hypotheses. Subsequently, there was a shift in thinking in the view that phylogenetic inference is a statistical problem. Thus, in the early 1980s, Joe Felsenstein introduced the idea that the likelihood principle is a way to infer phylogenetic hypotheses. Then in the early 2000s, there was the idea that Bayesian reasoning could be used to infer phylogenetic hypotheses. But in fact, none of these three approaches are philosophically or scientifically accurate ways to infer hypotheses. Parsimony is only a criterion for selecting among previously inferred hypotheses on the basis of some notion of simplicity. So, there is no method called parsimony capable of inferring phylogenetic hypotheses. The likelihood principle is only intended to provide a measure of support for hypotheses on the basis of test evidence. Likelihood, shown here, and its relation to probability refers to evidence E, where this evidence is test evidence. The evidence cannot be the characters that are in need of being explained. Just like parsimony, likelihood cannot infer hypotheses. Bayes' theorem, shown here, is intended to quantify changes in belief in a hypothesis pursuant to the introduction of new test evidence. As with likelihood, evidence E in Bayes' theorem refers to test evidence, not the characters we wish to explain. Bayesian reasoning cannot infer explanatory hypotheses since it requires that hypotheses be inferred beforehand. Indeed, the emphasis on treating phylogenetic inference as statistical has been a consequence of confusing the inferences of hypotheses with their being tested. Statistics is concerned with testing statistical hypotheses, not the inferences of such hypotheses. And it is fundamental to acknowledge that systematics is focused on the inferences of explanatory hypotheses, not statistical hypotheses. The only form of reasoning that can infer theories and hypotheses is known as abductive reasoning. Abduction is reasoning from observed effects, such as organismal characters, to hypothesized past causal events that might account for those effects. So, among all the attempts to characterize the inferences of phylogenetic hypotheses over the last 60 years, all have been nothing more than unrecognized abductive inferences, albeit those inferences have often been of questionable standing, given the failure to consider the goal of scientific inquiry and the nature of our why questions that lead to inferring explanatory accounts, among other problems. Since I just mentioned abductive reasoning, it's important to recognize that there are only three forms of reasoning within logic and philosophy, these being deduction, induction, and abduction, all of which were first introduced by Aristotle. Subsequent to Aristotle, however, formal logic only recognized deduction and induction for over 2,000 years, and this has had a strong influence on the development of the sciences. Abductive reasoning was ignored until the 19th century. It was because of the work of the American philosopher of science, Charles Sanders Peirce, that the importance of abduction to all of the sciences became recognized as fundamental, as well as in everyday living, and for characterizing the nature of perception. To his credit, Charles Peirce spent much of his life studying the nature of scientific inquiry, which led to his clearly articulating the operational relations between the three forms of reasoning. Abduction allows for inferences of theories and hypotheses. Predictions of potential test evidence occurs by way of deduction. And induction is the form of reasoning by which theory and hypothesis testing takes place. In fact, statistics is purely inductive, given that its concern is the testing of statistical hypotheses. Abduction has the following basic structure as a form of reasoning. First, we have effects that are in need of being explained. These effects comprise part of our premises of the abductive inference. Another premise will be a theory that states cause and effect relations. Another premise that might be necessary to stipulate is our background knowledge that is relevant to the other premises. From these premises, especially the conjunction of the theory to our observed effects, we then have the conclusion of a hypothesis or set of hypotheses of possible past causes that account for the observed effects. In other words, we have inferred a plausible explanation of observed effects. We can now consider the basic form of the abduction to a phylogenetic hypothesis. One premise will be the effects we have observed in the form of homologous characters. Another premise will be a phylogenetic theory, such as common ancestry. And our background knowledge would include the fact that we assume our observation statements of characters are true. This is a necessary assumption if the pursuit of explanation is to even begin. The common cause phylogenetic theory of common ancestry would be appropriate to explaining homologous characters, since we would want to maximize explaining those characters by way of common causes that can maintain as much as possible the integrity of our observation statements referring to shared characters. So, from applying the phylogenetic theory to observed characters, we conclude a phylogenetic hypothesis or hypotheses of past causal events that explain observed characters. The common cause phylogenetic theory ensures that ad hoc hypotheses of homoplasy are minimized, which again is consistent with explaining as fully as possible shared characters by way of events of common causes. While it's common to refer to phylogenetic hypotheses in the form of trees, it's important to keep in mind that phylogenetic trees actually imply multiple classes of explanatory hypotheses needed to explain observed characters. Ignoring those individual explanatory hypotheses in favor of only emphasizing phylogenetic trees has contributed to many of the problems in systematics, including the popularity of character mapping. The objective of systematics, as well as evolutionary biology, is to acquire causal understanding of homologous characters. That occurs by specifying particular explanatory hypotheses. Simply emphasizing phylogenetic trees, much less comparing tree topologies, cannot accomplish that explanatory objective. I want to add a brief note here regarding my comments on the previous slide as to the importance of using a common cause theory for phylogenetic inference. I invite you to read these two papers, which discuss important aspects of phylogenetic inference that are almost never taken into consideration in the context of scientific inquiry. These papers provide strong arguments for the need for common cause theories, among other relevant issues in phylogenetic inference. Based on what we have discussed so far, we can now clearly identify why character mapping is not a logically sound form of abductive reasoning, which precludes character mapping from being meaningfully accomplished. Once again, we will begin by considering the premise of observed homologous characters that are in need of being explained. We have a phylogenetic theory, preferably one emphasizing common causes, which has not always been the case, which again is a significant problem, especially because a theory not emphasizing common causes will be contradictory to our background knowledge regarding the truth of observation statements, and observation statements of homologous characters. I again refer you to my two publications I mentioned earlier where I address this issue. And here we have our background knowledge, which again assumes the truth of our observation statements. Now, where the critique of character mapping becomes critically important is that we acknowledge the additional premise in the form of a phylogenetic tree that was previously inferred only to explain sequence data. It's important to acknowledge that this tree is actually not relevant to any of the additional characters, such as the phenotypic characters we intend to explain, since this tree only implies the explanatory hypotheses causally accounting for those sequence data for which the phylogenetic tree was originally inferred. From these premises, especially applying the previously inferred phylogenetic tree to the phenotypic characters we wish to explain, we have the conclusion in the form of phenotypic characters mapped directly onto the phylogenetic tree, with the claim that ancestral conditions are indicated for each of those characters. The difficulty, however, is that the characters mapped onto this tree cannot indicate any hypotheses for the phenotypic characters. Reason the concluded hypothesis is logically unsound is that the phylogenetic tree used as a premise is entirely meaningless in this inference. It is simply not possible for this previously inferred phylogenetic tree to offer the means to explain characters or to explain other characters. Of course, this is all a consequence of the fact that phylogenetic inference has only recently been acknowledged to be a form of abductive reasoning, such that we have a clear indication of the content premises should take. The only solution available to us is to engage in proper abductive inferences to phylogenetic hypotheses, with logically and scientifically acceptable premises that are consistent with explaining homologous characters. In summary, character mapping cannot and does not produce phylogenetic hypotheses for the fact that a phylogenetic tree cannot serve as a premise. Finally, in addition to the improper use of phylogenetic trees that are not relevant to explaining phenotypic characters, there is another very strong argument against character mapping. This involves violation of the requirement of total evidence, which applies to all abductive and inductive reasoning. This requirement, first formally recognized in the philosophical literature in the 1950s, is an uncontroversial maxim of non-deductive reasoning. I have discussed in previous publications the importance of the requirement of total evidence to the abductive reasoning as it applies to the inferences of phylogenetic hypotheses. I encourage you to read the philosophical literature on this subject. Finally, I want to thank you for watching this video, and I hope this presentation has been helpful for understanding one of the important implications of recognizing that phylogenetic inference is an instance of abductive reasoning.